Hello everyone, welcome back to the session of data structures. In today's session, we are going to see what is a sparse matrix and how it can be represented. Let me share my screen regarding the PP of sparse matrix. After the end of the session, the learner will be able to know what is sparse matrix and what are the different types of representation of a sparse matrix. Before seeing the representation, we have to know what is a sparse matrix. Generally, in any programming language, if you want to define a matrix, if you want to represent a matrix, we use arrays. We use a two-dimensional array for representing a matrix. It means if a matrix consists of two rows and two columns, the matrix size is of 2 by 2 matrix. Similarly, in an array also, if you want to represent any matrix, we use m columns and m rows, but to represent a m by n matrix. Whereas we have some situations where in which we want to store more number of non-zero values than more number of zero values than non-zero elements. In such cases, we take a matrix called a sparse matrix, where sparse matrix is a matrix which contains very few non-zero elements and more number of zero elements. It means when we use the sparse matrix is that if you want to store more number of zero values rather than non-zero values, we use this sparse matrix. Okay, we have two types of representation of a sparse matrix. One is directly by the help of array and the other one is with the help of linked list. We already know what is array and also linked list. And the declarations and all. In these two ways, we can represent the sparse matrix. The array representation of a sparse matrix is also called as triplet representation. Let us see what is the array representation of a sparse matrix. Suppose this is an array. Suppose this is a matrix or array which consists of more number of non-zero elements rather than more number of zero elements rather than non-zero elements. Then how we'll represent in an array representation? See, in an array representation, this is the normal representation of an array. Okay, suppose we are having a matrix of 5 by 6. 5 by 6. It means 5 rows and 6 columns. We represent this matrix in this order, that the first column represents number of rows, the second column represents number of values, and the last column represents number of values. Here 5 means the total number of rows, 6 means the total number of columns, and this 6 is the total number of non-zero values. It means in this complete matrix we are having 6 non-zero values, that are 9, 8, 4, 2, 2 and 5. 6 non-zero elements. Then how we have represented all this? See, the first non-zero element 9 is present at 0th row, first column. 0th row, sorry, 4th column. Next one is 8. 8 is present at first row, first column. First row, first column. Next 4 is present at second row, first column, 0th column. Second row, 0th column. Next 2 is present at second row, third column. Second row, third column. This is how we represent a sparse matrix using arrays. And the other representation is linked list. In this linked representation, we represent the sparse matrix with two different nodes, namely one header node and the other one is element node. The header node consists of the index value. It consists of three fields. One is the index value, the next coming value, and its right side value. Its down value and its right side value. The element node consists of at which place the value is present, that is at which row and which column, and to the down to what is the element which is present, and to its right what is the element which is present. We can see this in detail with an extra example. This is the linked list representation of an sparse matrix. See, here we have a node. This is the row value, this is the column value, and this is the actual data what we are storing, and this one is downlink and this one is right link. So for every node you have the downlink and also its right node. This is how we can represent a sparse matrix with the help of linked list, where in this sparse matrix in a linked list is represented in a different manner. One consists of header node and the other one is one element node, where it consists of the element which is present down to it and the node which is present right to it. This is the representation of sparse matrix. Hope you have understood this. Thank you so much.